This video is on mass volume stoichiometry conversion problems. So this is very similar to a mass problem. The difference is one of those masses is going to be a volume instead. So I used this example in the last video. I said, okay, we learned how to convert moles of A to moles of B. And then in a mass problem, we just had, for example, grams of A that we converted to moles of A. And then when we converted it to moles of B, we converted that to grams of B. So all that's different in this problem is one of your grams, either side it could be, is going to be volume. So for example, this might be instead a volume, or maybe I'll actually use a volume unit, like decimeters cubed of whatever substance B is. All right, one last thing before we do this example is just a reminder that, and you might want to write this down, that 1 liter is 1 decimeter cubed. So good thing to point out, IB likes to use decimeters cubed. Sometimes you will see liters, but I need you to know that they are the same thing. And if you wrote liters for your answer, for example, that would be okay with IB. They just won't write liters. Now, in addition to this, 1 milliliter is the same as 1 centimeter cubed. So that also means that when you have 1,000 milliliters, if you remember, you'd have 1 liter. So 1,000 centimeters cubed is 1 decimeter cubed. So just a few reminders with some conversions there. All right, so let's do this example. How many decimeters cubed of ammonia will be produced from 10.0 grams of hydrogen? First thing we need, before I can even think about the numbers or units, is a balanced equation. So we have ammonia here and we have hydrogen, and it says ammonia will be produced. So ammonia is a product. That means hydrogen is a reactant. So if we're going to make ammonia, which is NH3, one you need to know, you have to think about what is missing here. So I hope you can see that the nitrogen is what's missing, and nitrogen is diatomic, so N2. So now to balance this reaction, I need 2 N's on my product side, which will give me 6 H's, so then I need a 3 here. All right, so now we have a balanced reaction. We can draw our path. So let's read this again. How many decimeters cubed of ammonia? So ammonia right here is my question mark, and I want a volume of that. And we're starting with 10 grams of hydrogen. So over here, I'm going to write 10.0 grams. So remember, the only way I can convert from one substance to another, so H2 to NH3, is in the units of moles. So I'm going to convert grams to moles of H2, then I can convert to moles of NH3, and then I'll be able to convert to volume. So the way we're going to do this is grams to moles, we're going to use our molar mass. So that's on the periodic table. Our moles to moles, that's our mole ratio. Remember, those are your coefficients. That's the 3 and the 2. And then moles to volume, that's what we call molar volume. And if you remember back chapter 3, or I think it was even in video 1 for this unit, molar volume states that 1 mole of a gas at what we call STP, standard temperature and pressure, which all of these will be at, will equal 22.7 decimeters cubed. Now this number IB does give you, so you don't have to memorize it. However, I assume you will do enough problems that you will know it anyway. All right, so let's do this. Now that we have our path and our reaction, let's start out with our numbers. So 10.0 grams of H2. So numbers, unit, substance. All right, my first step is to convert that to moles. So first thing I want to do is I want to get rid of grams of H2, and I want to find moles of H2. So this is my molar mass. So this is where I'm going to use my periodic table. Molar mass is related to 1 mole. And my grams are H2 on the periodic table. So 1.01 times 2, so 2.02. Now, the mistake I see a lot here is that students will want to write a 3 here where the 1 is. And you might see why, because there's this 3 in front of the H2 right here. But that only is for your mole ratio. So it's really important when you're doing grams and moles, and you're doing that molar mass, that you only write 1 whenever it's grams and moles compared. All right, so let's cross out what cancels. Oops, I want to do it in blue. So these 2 are now gone. So I've just converted to moles of H2. So I just did this step. So now let's do our next one. Now let's do our mole ratio, moles to moles. So let's get rid of moles of H2. And we're going to convert to moles of NH3. Now here's where that coefficient comes into play. So H2, I see a 3 in front of it. So I put a 3 here. And H3, I see a 2 in front of it. So I put a 2 here. And so now, now we can put a line through the moles of H2 because that is now divided out. So we just converted to moles of NH3, so we've got one more step to go, which is this one, to volume. All right, so let's get rid of moles of NH3. So down here to cancel. And I want to go to decimeters cubed, so that's my volume unit. And that's where I'm going to use this right here. So 1 mole, I don't care that there's a 2 in front of the NH3. 1 mole equals 22.7 for my decimeters cubed. So now moles of NH3 divide out. And I know I'm ready for my calculator because all my units are gone except for the ones I'm trying to solve for. So you can go across the top and multiply everything and then divide by everything on the bottom, or you can kind of do a section at a time. But practice typing it in just to make sure that you can get this answer with 3 sig digs, 74.9 decimeters cubed of NH3. So that is a mass volume conversion. Keep in mind, you could start with a volume and end with mass. It could be that. But it's going to have mass and volume, 1 on each end of your mole ratio.